Well, Hambini has a channel, and that channel generally he reviews products
5 years
and he
old.
roasts them. And we know that that's the word he uses. He likes to roast products. And some people argue to say, hang on, Hambini, a lot of these frames and bicycles you're getting are from people who have had a problem. They're not from people who haven't had a problem. And those bikes that you're seeing may just be the bad apple in the bunch, and they're not representative of the brand, the general population of that brand, and the quality of that brand. And what we need to really determine here is those people who are making the argument, have they really got a valid point? Or is the bicycle that Hambine's seeing a true representation of the general population of that product? Well, let's roll an intro and let's have a look at those arguments and see why one argument would probably outweigh the other. Well, the first thing we need to look at is the quality assurance that a manufacturer has. Now, quality assurance can be quite varied or it can be quite narrow depending on the product. And of course, if you're just making something like a can opener, you'd probably have a really wide variance because it's kind of going to work even if it's not made that well. Whilst if you're making a commercial aircraft part, you'd want the variance to be very narrow because you don't want any of those parts failing or not working properly when they're fitted to the aircraft, causing a significant accident, which then has huge consequences. So what we need to first look at is how that works. How this is normally done is you have a variance, you set a variance of your product. Now, to keep it simple, what we'll do is we will look at a bolt. Now, a bolt has a thread on it and it has a nut and it might have a pitch. And let's just argue that that pitch is 5%. Now, if the pitch varies by 1 degree to 4 and the nut varies to 6, then the thread is going to start to get tight. So what we'll do is we'll set our variance at plus or minus 1 degree on the thread, because if one's fully one way and the nut is fully the other way, it's going to start to bind and it's not going to thread in correctly. So what we would set our variance of those two products by 1%. So what we do is when we make our products, we generally have a distribution curve, and that's like a bell shape, they call that. And generally they set their sigma that they want to work to, and generally we look at about 3 sigma, which is I think 97.5%, if I remember correctly. Now, that doesn't cover the whole percentage, but what you would do is you would have some way in your quality assurance to do random audits or a full audit of all of the products, and you'd have some way of testing them to make sure that that variance or that thread is not going to go out. And what you might do is you might just screw it in and screw it out. And if it doesn't bind, then you pass it. And that's how you test it. So once one binds, then you would put it aside or put it in a bin that's for the discharge of that product, and you're not going to use it. It's a reject at the factory before it goes out the door. Well, this is how all products should be quality controlled or quality assured. And the reason why you do that is so you don't have any products going out, or you have a very small percentage of products going out that are outside of those variances. And what you'll find is most of the products will tend to be around the 5-degree mark on those bolts and nuts, because that's the middle, and that bell curve, you'll have the most products at that point. So that's how the manufacturing works, and that's how your quality assurance works. Now, when we look at bikes, and we get a bike that's going to Hambini, even this person's got it and he's had problems, we send it to Hambini, the tolerances, if we just compare it to that bolt, should not be outside 1 degree of the thread. So you put the bike together and it should work as advertised. And if you put your bearings in, your crank in and that, yeah, it might not be as good as if it's a perfect dead center, perfectly 5% pitch, but it will still work. And as I said, with the nut and the bolt, it'll still thread in. It will still work as it was designed to work. But what Hambini's finding is these bikes are really not fit for purpose, because what the bike is doing, it's wearing out bearings prematurely in the bottom brackets. So therefore, that it isn't fit for purpose. Having a bike and riding it for a month or two and the bearings are basically had it is not considered a fit for purpose product, and that frame should have been rejected at the factory level. So even though it might be a bad apple, that might not represent all of the products that came out of that factory, the factory shouldn't have let it go past the doors and gone out into the real world. And that's why it still is a bad indication from that product. Even if that was the only one that was that bad, you go, hang on a sec, your quality assurance of the company is not working, which means that there could be more, because it's allowing products out the door of that factory that are not within the company's set variances that they've designed. So when the bike is made, it works as advertised as the engineers designed it. So in conclusion, unless we go and get a whole lot of batch of these products from that factory, like just say we go and buy 50 or 100 frames and we compare them and see how they vary, we probably don't really know from a reality point of view. But we do know from a technical point of view, when we look at standards and the way manufacturers are supposed to make things, is that it should not fall outside the variance. And if it does, it should be rejected at the factory level. Now, just on a side note, there is a video, and I'll see if I can find it, and I'll link it up the top, that was from Leisure Technique. That's Rail over there down in Melbourne in Australia. He's one of us Australians, but he's over there on the East Coast. And he actually had 2 Colnago C60 frames. And when he checked them and looked at them to see if there was voids or porosity in the frames were amazingly similar. And this makes sense because the manufacturing process, the way they make them, would be done the same way. Be put into the same jigs, there'll be the same layup, there'll be the same resin, there'll be the same compression. And you would imagine that the frames would tend to be very similar. They wouldn't like have this big variance that we're arguing if these frames are bad and, oh, that's just a bad apple. And they were very, very similar, which gives us an indication that the frames are actually made pretty consistent. So if they're made bad, they're made bad consistent. So as far as I see, I do think this does place a negative angle on the company. Even though we may say that's a bad apple, and maybe, let's just say it is right out there on the edge of the variance, it still should be fit for purpose. Every bike that leaves the factory should be tested. It should be made sure that it works as advertised, as designed. And if it doesn't, if the variances are too far out and they're letting those out into the real world, then that still falls back on the manufacturer, because he's not applying his quality control very well. And if he's finding those, like, there should be audits done, and if they detect that they do find these ones that are out of tolerance, what they need to do is then start testing more of the products that are going out the factory to see if this is just a one-off, or this is a percentage of the bikes that are going out that aren't meeting the design criteria. Well, anyway, guys, I hope that explains it, and you really can't just argue that all of the bikes that Hambini doesn't see are okay and this is just a bad apple, because yes, we only have one sample, Hambini has one sample, but on the flip side of the coin, we're not seeing a huge percentage of samples to compare if they are. So we don't know if all of those other bikes that are being sold are the same or if they're significantly better. So at this point in time, we don't know. But what we do know is the manufacturers should be keeping all of the frames and all of the bicycles leaving their factory within those set variances, which are set on their bell curve, and they're set by the manufacturer. They're not set by someone else, unless it's something like a bearing, and the manufacturer of the bearing says, for this bearing to have an interference fit into the frame, the variance of measurement of the side of the hole needs to be this much. So it's not too tight, it's going to crack the frame, and it's not too loose, it's going to fall out. So other components made by other companies may set the variance for the manufacturer to make the frames to. But even still, then you go, oh, hang on, this one's too tight, or the bearing falls out, and we're not going to let this one out of the factory. That's in the discharge or reject bin. Anyway, guys, Leave your comments down below. What do you think? Do you think that Hambini's really an eye-opener, or do you think, nah, mate, he's just getting the bad apples? And I don't believe that that's representative of the products that are coming out of these factories. And also, if you could do me a big favor and also subscribe down below and smash that like button to help the algorithm. And I will see you next vid.